Hello guys, welcome to the session today. Today we are going to do the first problem set, question number 1 from the series 6042 Mathematics for Computer Science provided by MIT, and the course is presented by Tom Leighton. You can find this course on YouTube, and you can also find the reading material on their OCW website. Great, let's get started. So this is the question that we are going to do today. The question asks us to translate the following sentences from English to predicate logic. Now, one thing you need to understand about predicate logic is that there are words that are notified by symbols in predicate logic, right? So I will keep telling you along the way about those symbols so that you can understand it properly. The domain that you are working over is X, the X set of people. So the set of people that we're working with is X. You may use the function S of X, meaning that X has been a student of 6042. So there's a course called 6042, the same course from which this assignment was given to us. And we are saying that if S of X is true, then X has been a student of the same course. Another function we can use is A of X. That means A has gotten an A in the same course. That, like, this statement has two statements in it. A once like in A of X, if a person has taken the course and they have also aced it, they have received an A in it. Next function is T of X, meaning X is a TA of the course. Of course, TA means the teaching assistant. And last function we are given is E of X, Y, meaning that X and Y are the same person. So first thing we need to do is get all of these symbols noted in a different paper. So I've done that for you here. Now let's get started with the problems. The first sentence that we need to translate is, these people who have taken 6042, there are people who have taken 6042 and have received an A in it. So there are people. So for there are people, we use a symbol called there exist, and it is denoted by that symbol. So there exists some X, right? Some people from X, right? Element of the set of people such that S of X and S of X, that means people who have taken the course 6042 and received an A. That is what we want to have here. So they have received an A, and this is the function for that notation. So we'll say S of X intersection A of X is true for these people. This is the function for the first. Now let's talk about the next sentence. Next sentence says, all people who are 6042 TA have taken 6042, got an A's in the course. So this statement is kind of like the result of these two things. So like if a person has taken a course and they are TA, they must have had A's in their grades. So it will look kind of like this. So for all, we use this symbol. So this means for all. For all X elements of a set that includes of the people of the set of people, a few people of this set have done the course and they are in T of X, right? If this is satisfactory, only then, only if and only if we have received A in it. That's why this statement, all people who are in 6042 TAs have taken course, got the A's in it. So like if this is true, this must be true, right? This is implied for those people who have taken the course, and those who are TA, they must have had A's in their grade. Now let's talk about the third statement. It says there are no people who are 6042 TA who did not get A's in it. So simply we can just make negation of the same sentence. We can say there are no people, right? So we'll, like, for a starter, since we have to say there are no people here, there are no people, so we'll, instead of this, we'll just remove this no for the time being, and we'll deal with it in the end, and we'll say there are people who are TA and did not get A's. So here there exist X who are element of X, and they are element of TX, but they did not get into this function, right? And now in the end, simply we can just say there are no people. We have put a negation here, so we're good, right? So that's how you deal with the sentence that says there are no people who are TA of 6042 and did not get A's in the course. For the fourth question, there are at least 3 people of TAs in 6042 who have not taken the course. Okay, so there are 3 people, right? There are at least one X, there's at least one Y, there's at least one Z, okay? Such that element of the group, that is S, and now we have to show that these people are not same. So we'll say not group of XY and not element of XZ and not element of YZ. Okay, so we'll put this in a black bracket here, and now we'll say that these people are in the TA program but they haven't taken the course. So this should look like this. Element, these are element of T of X but not an element of S of X, right? So here we've done this for X, we also need to say the same thing for Y and Z. So I accidentally wrote Z here first, so I'll just go for Z, then I'll just do the same thing again for last variable, that is Y. I'm going to write here Y, not an element of Y, right? So that's how it goes, ladies and gentlemen. That is the predicate for the last statement that we had. And that we have solved the question number 1 for assignment 1 of the course Maths for CS. Thank you.